Good morning, everybody. Today we are continuing 6-3b, and this is the actual lesson of 6-3. It's called Distance and Midpoint Formula, which is related to what we have learned before, which is the Pythagorean Theorem. So let's actually do a review that is involving Pythagorean Theorem. Recall that in the Pythagorean Theorem, you have a right triangle, and these two sides we call the legs, and then the slanted side is not touching a right angle is the hypotenuse. So our goal here is to find what is the length of the hypotenuse. To find the length of the hypotenuse, first we have to identify the legs are the variables A and B, and then the hypotenuse, which is not touching the right angle, is always just C. Remember, you could interchange the letters A and B's, but you cannot change the C. The C is always the hypotenuse. So to find the length of that, you use the Pythagorean theorem, which is A squared plus B squared equals C squared. And then from there, you're going to substitute A with the number 5, the B with the number 7, and C, just keep it as C. So A is going to be 5 squared plus, and then B is going to be 7, and then you copy the square, is equal to C squared. Then from here, you square each number. So 5 squared means 5 times 5, which is 25. And then 7 times 7, which is 49, is equal to C squared. Then at the end, you add 25 plus 49, and you will get 74. So 74 is equal to C squared. Now remember, your answer is not 74 because this line looks too short to be 74 units long. I mean, if this is 7 units, this is going to be just a little bit above 7. It's just a tad longer. It's just a little bit longer. It's not going to be as long as extreme, which is like 74 units long. So the opposite of square is going to be square roots, like this. So that means your C is going to be square root of 74 units long. And to find the decimal, we're going to find the square root of 74, which will get you 8.6023, so on and so forth. But we're going to write in 2 decimal place, so it's going to be 8.60. So its C is going to be 8.60 units long, or just 8.6 will be just fine. So that means this hypotenuse, the length of it, how long it is 8.6 units long. And the hypotenuse is always the longest side in a right triangle. Doesn't matter what kind of right triangle. The side is not touching the right angle is always the longest side compared to the other two sides, which are legs in the right triangle. Well, that's the review to how to do Pythagorean theorem. And in the next lesson will be a continue and extension of this Pythagorean theorem. In lesson 6-3b, we're going to take a look at something called distance formula and midpoint formula. Let's talk about distance formula first. It's going to be a very long square root, and inside the square roots, there are 2 parentheses being squared. And inside of parentheses, there is a difference between the x and a difference between a y. So if you have an order pair, the first order pair we're going to call x sub 1 and y sub 1. And the second order pair we're going to call it x sub 2 and y sub 2. Kind of like how you find slope between 2 points back in the days, where the first point is x sub 1, y sub 1, and the second point is x sub 2, y sub 2. So to do that, let's take a look at 2 methods of finding the distance between the 2 ordered pairs in example 1. So in example 1a, it says find the distance between -3, 1 and 2, 3. So to find the distance, what you do is you're going to first label the ordered pair where you have -3, 1 and 2, 3. And the first order pair is going to be your x sub 1, y sub 1, and then your second order pair is going to be x sub 2, y sub 2. Well, let's use this formula. We're first going to recopy the distance formula. So d is equal to square root of, and then I'm going to leave the 2 blanks, leave the x's with 2 blanks. So I'm just going to copy the minus. And then same thing with the y's. I'm just going to write parentheses to the second power with a subtraction sign in between. So let's actually match the letters. So x sub 2, which is 2, we're going to put it right here. And then x sub 1, which is -3, so we're going to put -3. Now be careful, there is double subtraction. There's a subtraction from the formula, and there's a negative sign from the x sub 1 value, which is -3. Then we're going to continue. Y sub 2 is 3. and y sub 1 is 1. And then from here, we're going to use order of operations to simplify everything. Let's simplify everything inside of parentheses first. So d is going to be square root of, now 2 minus negative 3 is 5 squared, plus 3 minus 1 is 2 squared, like this. And then from there, you're going to square both numbers. So 5 squared is 25, 2 squared is 4. And then at the end, you're going to simplify 25 plus 4. You get d is equal to square root of 29. To find out what is the square root of 29, we're going to use our calculator and find what is square root of 29. And you get 5.39 approximately. So that means the distance between them is 5.39 units long. Okay, so that's the distance between the ordered pair negative 3, 1 and 2, 3. Let's take a look at the picture. I want you to focus on this picture. We're pretty much finding the distance between this point and this point. And this seems to be just a little bit, around 5 units. Because remember, each unit is this long. So if you were to put, 5 of these on this line, it should be about 5.39 of these units long from here to here. Now let me show you another way. For those who does not like to use the distance formula, there's actually another way to do it. So I'm going to just write another method here. Remember, we learned Pythagorean theorem before. So what you're going to do is, remember, this is a hypotenuse, right? It looks like a slanted side. So what you're going to do is you're going to draw a right triangle. So there's 2 ways to draw a right triangle. You could draw like a base and a height like this. So you see there's a right angle here. Or you could draw upside down like this as well. And then you kind of count. Well, how long is the base? So you count 1, 2, 3, 4, 5. So that means this is 5. And here's 1, 2. So it's going to be 2. And then from here, you could use Pythagorean theorem, right? So, let's take you back to a squared plus b squared is equal to c squared, where your base is just 5 squared. And then your height is 2, and you square that is equal to the hypotenuse squared. So 5 squared is 25, 2 squared is 4, right? Now, I want you to take a look at those numbers. Aren't these numbers pretty much the same, right? So it's just that, when we count the difference, we already, counted without subtracting the x coordinates. And same thing, we already count how far between the y, so we didn't have to subtract the y coordinates. So let's actually continue. So 25 plus 4 is 29 is equal to c squared. And to undo the square, you take the square root on both sides. So you get c is equal to square root of 29, which is same thing as 5.39 units long. Now, of course, it's easy to count because, here we're able to count how far and how long it is when we have a picture. But sometimes if I were to cover it and we don't have a picture, sometimes it's really hard to count. So I still prefer you to use the distance formula to find a distance rather than, draw a picture and count how far. Because sometimes if these numbers get too large, you're not able to count, what is the base of the triangle, what is the height of the triangle, and then from there you use the Pythagorean theorem. You cannot really do that all the time. Okay, so I'd rather have you practice the distance formula. Let's try another example of distance formula. Here we have larger numbers in the order pair. We have negative 30, negative 25, and negative 5, 20. So let me recopy that onto the piece of paper, and we're going to label them as x sub 1, y sub 1, x sub 2, y sub 2. Then from there, we're going to recopy the formula. So the distance formula is something, right? The x subtract square plus the y subtract square. So it should be x sub 2 minus x sub 1. So you're going to replace x sub 2 on the first slot, x sub 1 on the second slot. Again, watch out for double negatives. And then on the second parentheses, you subtract y sub 2, which is 20. And then the y sub 1 is negative 25. Again, watch out for the double negatives. Okay. Then here, you're going to simplify the negatives. So negative 5 minus negative 30 is 25 squared plus, and then 20 minus negative 25 is 45 squared like this. Okay. And then from here, you are going to, simplify the squares. Now, there is a discrepancy between the paper the order pair and the graph, right? The graph should have been this order pair here. So let me fix that. So this is not the point. This is the point actually, right? So this point is -30, -25. And then this point is -5, 20. So these are the 2 points. Well, let's continue on the distance formula. So 25 square, I need to use a calculator. So 25 square, and I think there's a square button, is 625. So we're going to put 625 on the next line. And then 45 square, so 45 square like this, I get 2025. So 2025, you notice that these numbers are large, right? And then I'm kind of running out of space, but I could just write it here. So 625 plus 2025 is 2,650. And you need to find out what is the square root of that. So I'm going to type in square root of 2,650, and you get 51.48. Okay, so it's approximately 51.48 units long. Okay. Now, of course, same thing, you're able to kind of cheat a little bit by using the Pythagorean theorem. It's just that it's not going to be nice when you count it, because remember, in the coordinates, each of these is 5 units long. So if you were to count 1, 2, if I really were to draw a right triangle, let's say if I were to draw the hypotenuse. And if I were to draw a right triangle like this, so we go down, and then once you get as low as the first dot, you're going to go, even with that. So you see that there's 5 units here. 1, 2, 3, 4, 5 units on the base, but each unit is 5. So you do 5 times 5, which is 25, and that's why I get 25 here. Likewise, on the height, you should see there is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 boxes, 9 blocks. But each block is 5 units long, so you do 9 times 5, and you get 45. So same thing with Pythagorean theorem, but again, if I were to cover this picture, it's really hard to use Pythagorean theorem. So I still want you to use the distance formula to find the length between the 2 points. Well, the next example is finding the midpoints between 2 ordered pairs. What is the midpoint? The midpoint is just like what it says, is that if you have 2 points, I want you to plot where is the middle of the points. Now, of course, if you were just to examine it visually, now the middle between these 2 points is definitely not going to be here, not going to be here, but it's like somewhere maybe here, right? Like just like in the middle. So we're going to find exactly what is the order pair of that point right in the middle. Maybe it's right here, I don't know. So let's actually find it out. I kind of just made a little mark here, but let's just find it out. So to do that, it's very, very easy. So recall that the midpoint formula is x sub 1 plus x sub 2 divided by 2, and then y sub 1 plus y sub 2 divided by 2. Remember back in the days you learned how to find mean, median, mode? And remember the mean, where if you have to find a mean of 2 numbers, don't you add them and divide it by 2? That's exactly the same thing of what we're doing. So if you have 2 x's, you just find the middle of them. So you find the mean of them. So you just add them divided by 2. Same thing, if you were to find the middle of the y, right, there's 2 values, you just add them and divide it by 2. It's like, finding, or also median as well. If there's 2 middle numbers, you add them divided by 2. So it's really related to what we have learned in the past back in topic 10 when you learn how to find a mean and median, because you just add them and divide it by the number of numbers there is, which is just 2 order pairs only. So it's 2 on a denominator. So let's write it out again. So to find the midpoint, I'm going to recopy the order pair, and I'm going to label that as x sub 1, y sub 1, and x sub 2, y sub 2. Well, let's actually apply this formula. So to find a midpoint, I'm going to use a capital M, and it equals, and then add the x's together, -3 plus 2, -3 plus 2 divided by 2, and then the y's together, right? So 1 plus 3, so 1 plus 3 divided by 2 like this. Then from there, you use the order of operations to simplify that. So -3 plus 2 is -1 over 2, and 1 plus 3 is 4, so 4 over 2. Now, -1 divided by 2 is just -0.5, and then 4 over 2, it's just 2. So that means the order pair of the midpoint is -0.5, comma 2. Let's actually plot that to verify. So -0.5 would be right here, between 0 and -1, and then comma 2, you just go up 2 units, and then I plot, hey, that looks like the middle between this dot and this dot. It makes sense. So therefore, I know that my answer is correct. Let's try another one. In example 1b, same thing, you're going to find the midpoint between 4, -2 and -3, 5. Well, we first need to write out the formula as well as labeling the order pair as x sub 1, y sub 1 and x sub 2, y sub 2, like this. Then the formula says, remember, it's going to be you add the x's divided by 2, and then you add the y's divided by 2 to find the midpoint. So you're going to write m equals, go ahead and add the x's together, 4 plus -3. So 4 plus -3 divided by 2. And add the y's together, -2 plus 5 divided by 2. Okay? Then use order of operations to simplify. Let's add the numbers first. So 4 plus -3 is 1 over 2. And then -2 plus 5 is going to be 3 and then over 2. Well, 1 divided by 2 is 0.5, and then 3 divided by 2 is 1.5. So that means the order pair of the midpoint is 0.5, 1.5. Again, we could plot that to verify. So 0.5 is right here, and then 1.5, it's right, oh, sorry. So again, we could use the graph to verify to see whether our answer is correct. So 0.5 would be here, moving half units to the right. And then 1.5 would just go up 1.5 units, so right here. So this is the order pair 0.5, 1.5. It looks kind of like right in the middle, so I know that my answer will be correct. Well, that's pretty much it for this lesson. You have two formulas, midpoint formula and distance formula. And in the next couple minutes, we'll remind you how to log on to your Pearson's homework. Thank you.
Hey everyone, so to get to your homework, first you go to my CNUSD website and then you click on the top of the page, my CNUSD, to log in. Well, you're going to type in your username and your password. Well, in this case, your student ID and your password. Then you go on to resource. I think for you guys it's resource. And then you go to a place called Pearson Savas Easy. Pearson Savas Easy. I'm not quite sure how you say that word, but it's Pearson Easy. Click on that. And you get to this pop-up page. And you're going to click on your class textbook. So you click on this right here. This is called Envision Integrated Mathematics 1 2009 Common Core. Click on that, a new window pop up again, and you see 3 different colors. The green color is your online textbooks. I teach from this textbooks, so if you don't have a copy, an actual copy, you could always go to here and click on the appropriate sections that we're teaching. But to find your online homework, you look at the reddish, orangish box in between, in the middle. It's called classes. So you're gonna click on here, click on classes, and depending on which period you're in, there will be new assignments here. So you're going to click on the click into the assignments, and then do your homework, and then that's it. Well, inside the homework, there are problems for you to work on, which allow you 3 attempts before they give you the final answer. So for example, for this problem, if you accidentally got a wrong answer, it'll tell you keep trying. Then you type in another answer, and if it's wrong, then it'll give you one more chance. And the third time that you got it wrong, it'll tell you the answer right away. So, but you could always get help by viewing an example on this part of the feature. So it'll tell you what to do step by step, step by step, step by step until the final answer. So you could always refer to the question, help view an example, or you could use help me to solve this to actually work it step by step. So there will be more answer boxes for you to fill in, but at least it will help you on your learning. Now for this problem, what do you do when you get it wrong, right? So well, to get a point or to get scores on that homework, then you click on similar questions and you keep practicing until you get it right. So if I were to click on similar questions, you notice that the questions changed. It's different from the previous one. So let's say this time you got it right. Let's say x is equal to 5, right? Well, if you got it right, it will tell you well done, okay, and then you move on to the next problem. So you click on next to move on to the next problem, like this. And once you finish all the problem, I believe the next thing is for you to make sure that you answer all the questions. If there's anything that it's not answered, make sure that you go back and look at it like this, right? So this is not answered. But let's say assume that if you finish your all of the questions on your homework, then you go to the bottom, I believe. Oh, actually, this button right here says submit my work. So you click on it, and then boom, I only got 3% just because I only answered one question correct, the rest I did not answer. So in order for you to get at least 80% or any good scores, make sure that you answer every single question and it's correct, not incorrect, for you to get as many points as possible on your homework. If you have any questions, please contact me.